All right, we're now going to move on from constant speed to constant acceleration. Okay, and the equations for that are going to be, there's going to be three of them. So v equals v0 plus at, and I'm going to define these variables in a bit. V squared is v0 squared plus 2a delta x, and delta x is v0t plus 1/2 at squared. All right, and we need to define these. So v0 is the initial speed. V is the final speed. A is acceleration. And we know that delta x is displacement or distance. And t is time. And maybe we should put the units for these here. Time is going to be in seconds. Speeds are in meters per second. Acceleration is going to be in meters per second squared. And displacement is in meters. And I haven't actually defined acceleration. And acceleration in physics has a slightly different meaning than it does when we normally talk about acceleration. In English, when we say acceleration, we mean speeding up. But in physics, acceleration is any change in velocity. Okay, I can speed up, I can slow down, or I can change direction. And all three of those are accelerations. All right, and we're going to deal with speeding up and slowing down in this unit, and then changing directions in a unit that's coming up. So how to solve these problems? Okay, because where people go wrong is they pick an equation and try to stuff the information into them. Before you do that, what you should do is identify three givens. And then identify your unknown, what you're looking for. Then choose an equation. And then plug in and solve. Okay. So we're going to do some examples. All right. I have a car that's starting from rest, accelerates to a speed of 30, and covering a distance of 60. So anything that's a number is obviously a given. So I have a speed, and that's at the end of the problem, of 30. So v, we're going to say, is 30. Okay, because v stood for the final speed, the speed at the end of the problem. Distance is going to be our delta x. So that's going to be 60. And then I said we have to identify three, and there's only two numbers in here that are obvious. But this right here is telling me something. That means it starts with a velocity of 0. So my initial velocity is 0. And then I have to find my unknown. And my unknown, this says what is the acceleration? So I'm looking for a. All right. So now, and this is part A of the problem. Now I'm going to plug in to one of the equations. And I have to have the one that has v delta x, v0, and a in it. So if I look at this first equation, that's not going to work because it has t, and t isn't in my list. The second one will work because I have all of those variables. So I write the equation down. And then I plug in. So my v was 30. v0 is 0. And delta x is 60. And that's all of the physics. From here on out, it's just an algebra problem. So 30 squared is 900. 0 squared is 0. I don't have to worry about it. And on this side, I can do the 2 times the 60. So I get 120a. Then I'll divide both sides by 120. And I end up with a is equal to 7.5 meters per second squared. You'll notice I didn't show that dividing step. Okay. In math, they're very particular. You have to show every single step. In here, you don't. Okay. And I will often skip steps like that. And then next to that's how much time does it take. So I'm looking for t. Two of my equations have t in them. And I could use either one at this point because I know lots of stuff. But this one's going to be way easier because it's a simpler equation. So I'm going to pick that one. So v equals v0 plus at. So v was 30. v0 is 0. I don't have to worry about it if it's 0, so I'm just going to cross it out. A we just found was 7.5. In t, I don't know. I would divide both sides by 7.5, and they end up with t equals 4 seconds. Okay. Next example. A car traveling east slows from 30 to 20 in 4 seconds. So v0 is 30, because that's the speed it starts at. The ending speed is 20. The t is 4. And then I'm looking for the acceleration. So again, I'm going to find the equation that this one needs to have v0, v, t, and a in it, and not delta x, because that wasn't on my list. So if I look, I end up with this one right here at the top. So v equals v0 plus at. 20 equals 30 plus a times 4. We'll subtract 30 from both sides, and that's going to give me minus 10 equals 4a. And a is minus 2.5 when I divide 10 by 4. So there is my answer. What does the negative mean there? It really means direction. The car was going east, but it's slowing down. And you can think of the acceleration as a push. So we have to push it back west for it to happen. So we could also write a is 2.5 meters per second squared west. All right, then part B, it wants displacement. Displacement is delta x. So I could plug into this equation. V0 was 30. T was 4. A is minus 2.5. And T was again 4. I got to remember to square it. So this part here gives me 120. This part, I'll do it step by step. Half of 2.5 is 1.25. And it's going to be negative because, half times negative 2.5 is negative. And then 4 squared is 16. Multiply those out and I get 20. So then delta x is 100 meters. All right. And then my last one, sometimes you get problems that don't have any numbers, and some people get intimidated by these, but you solve them the same way. Find 3 givens, find what you're looking for, pick an equation. So a car starts from rest. That's going to tell me v0 is 0. Accelerates with an acceleration a. So I'm just going to put in my acceleration equals a. Determine the distance. That means delta x is what I'm looking for. And I want to reach a velocity v. So my final velocity I'm just going to call v. Then I would look at my equations, and I want the one that doesn't have t in it, that has v0, a, delta x, and v. And I'm not going to bother flipping back over, but this is the equation. Then I could plug in v squared equals v0 is 0, so I don't have to worry about that part. 2a is capital A, and then delta x. trying to solve for delta x because this is what is delta x. So I'm going to get that by itself. I'm going to divide both sides by 2a. I'm going to cancel over here, and I get delta x is v squared over 2a. All right, now, if the velocity doubles, what happens to the distance traveled? And we're going to spend more time on these types of problems, but I'm going to show you one way to do it right now. We're going to do the problem twice. We're going to pick a velocity and an acceleration. Okay, so I'm going to find delta x1. All right, so I'm going to pick a velocity. You pick any number you want. Let's pick 2 because that's easy to work with. All right, and let's say the acceleration is 1 because I can pick any number I want. All right, then I'm going to delta x1 is v squared over 2a. I'm going to use this equation. V was 2, so 2 squared over 2 times 1. 2 squared is 4 divided by 2, I get 2. So delta x1 is 2. Okay, now let's do it again because I want to see what happens to it when the velocity doubles. So I'm going to double the velocity. So now the velocity is going to be 4. My acceleration is still going to be 1 because it says double the velocity. It doesn't say do anything with the acceleration. Rewrite my equation. I put 4 in there for v and square it, divided by 2 times 1. And if I do this, I get 8 because 4 squared is 16 divided by 2 is 8. Well, by what factor did it go up? It's 4 times as big. So when velocity doubled, the distance doesn't double, it becomes 4 times as big.